Let's start by finding the volume of the room, which is the length times the width times the height of the room. And we're given that it's 4 meters times 5 meters times 3 meters, and that gives us 60 cubic meters of volume. And now we can say that the mass of air from the density equation is going to be the density of air times the volume. And if we look up the density of air, we find out it's 1.2 kilograms per meters cubed times our 60 meters cubed of volume will give us 72 kilograms. So that means that the weight of the air is going to be our mass times g, acceleration due to gravity. So we have 72 kilograms times 9.8 meters per second squared, which will give us 705.6 newtons. And if we take into account significant figures, then we can say this is 700 newtons. Similarly, the mass of water would equal the density of water times the volume, and the density of water is 8,000 kilograms per meters cubed times our 60 meters cubed of water, which gives us 6.0 times 10 to the 4th kilograms. And now the weight of the water is going to be the mass of the water times G, which is 6.0 times 10 to the 4th kilogram times our 9.8 meters per second squared, and that gives us about 5.9 times 10 to the 5th newtons. And now if we want to look at the pressure and see how much the downward force, we can say that the force is equal to the pressure P, not the density, the pressure times the area. We're told that the pressure is 1 atmospheric atm, so this is the same as 1.01 times 10 to the 5th pascals per atm. So we need this conversion factor. And the area is the 4 meters times the 5 meters, which is the length times the width of the room. And notice that a pascal is the same as a newton per meter squared. So these meter squares cancel, leaving us with just a newton. And if we do this, we get about 2.0 times 10 to the 6th